All right, welcome back, guys. So in today's video, we're going to go over another problem from chapter 3. And in this question, we have this I-beam that has a mass of 450 kilogram and it's supporting the load, which is 220 kilogram. We need to determine the reaction at the supports. Please make sure to subscribe to the channel and share it with your friends. It's going to help me to grow the channel. So as always, we're going to start with the free body diagram. And let's see what we have in the free body diagram. So let's start with the beam in here and let's see what we have. So we have two supports at point A and B, and there is a video, I'm going to put the link in the description below, that shows different reactions that we have at different supports. It's going to help us to figure out what kind of reactions we have in each of these different supports in 2D and 3D questions. So if you need a reminder, feel free to check that video out. It has all the reactions. So as we can see at point A, we have a pin, which means we have both X and Y component. Let's call it AX and AY, and since it's a pin, it can rotate freely, so we don't consider any moment. And if we look at the beam, we see that we have a uniform beam, and the length would be 5.6 plus 2.4, which will be 8. And since it's uniform, the centroid would be exactly at the center, which is somewhere in here, and we know this distance is 8 divided by 2, which is 4, and the unit is meter. And if we want to find the force, we simply have the weight, which is mass time gravitational acceleration. So we will have 450, which is the mass, times g, which is 9.81, and that will give us a Newton force. And we have also another force, which is the load, that we know it's 2.4 meter from the other end. And similarly, we have the same thing, we have mass times g, again Newton. And we have the support B, which is a roller, which means there is no component or reaction at point in x direction. We only have y direction, and let's call our x and y the positive direction this way, and let's call that by, and that would be all the forces that we have for the free body diagram. And we can move on to our equation. So we are in equilibrium, so since we are in equilibrium, we have sum of all forces equals 0, and same for moment. So we have sum of all forces in x and y direction. Let's start with the x. And if we look at the free body diagram, we see that the only x component that we have is ax. And since we are in equilibrium, this has to be equal to 0. That means ax is 0, and that would be our first reaction. Let's move on to the Fy, or the moment equation. Looking at the question, we see that we have two unknowns in y direction, which is ay and by, which means we cannot find the unknown with Fy. So let's just hold on that for now and move on to our moment equation. We'll see that we can go either with A or B, and once again counterclockwise positive. So we can do, usually we go with the point that we have the most unknowns in here. It's A, but we already know Ax is 0, so not much different going for A or B. Let's go with A, see what happens. And for that, what we have is the moment of the beam, which was 450 times 9.81. And if we look at it, we'll see that the moment about A is counterclockwise, which means it's negative. So we'll have negative 450 times 9.81 times the distance, which is 4. By the way, we have a video for finding the moment in 2D questions, and that would be the shortcut that I'm using now. I'm going to put the link in the description below. Feel free to check it out. And so basically what we need in here is just the force times the distance to the point that we're finding the moment about. So in here we have 4, and the force was the mass of the beam. So that's the first. We have the same scenario for the load, the 220 load that we have. Again, the moment is clockwise, which means it's negative. And we have this time minus 220 times 9.81. And if we look at the distance, we will see we have this distance in here, which would be 6 minus this distance, which is 2.4. And if we do that, we'll get 5.6. And that would be the force, that would be the moment for the 220 kilogram load, and one more thing left, and that would be the By. This time we'll see that the By is counterclockwise moment, which means it is positive. So we'll have plus By, and the distance will be the length of the beam, which was 8 equals 0. The only unknown that we have in this equation is the force By, and we can find By simply 3,720 Newton. And that would be the second unknown. Obviously, there is one more left, and we have one more equation too. And for that one, we will have the sum of all forces in y. And what we have for y is ay plus by minus 450 times 9.81 minus 220 times g. Again, since we are in equilibrium, this would be equal to 0, and we have by, we already found in the previous step, 3720, and we can find a by in the last part of the question. So that would be everything for this question. Please make sure to subscribe to the channel and share the content with your friends, and I will see you guys next time.